Now, with the quotient rule of any function x, let's say you have the numerator of x divided by the denominator of x. What you want to do with this, the derivative of that function is going to be the derivative of the numerator times the denominator. Then you subtract the numerator times the derivative of the denominator, all divided by the denominator squared. Now notice with this is a subtraction sign, so the order in which we do this matters. Now let's take a look at an example like that. Let's go ahead and look at some function f of x is equal to 2x minus 3, all divided by x plus 5. Now, the numerator of x is just equal to 2x minus 3. The derivative of that numerator is just equal to 2. The denominator of x is equal to x plus 5. And the derivative of that denominator is just equal to 1. So to find the derivative of our original function, I take and multiply the numerator times the derivative of the numerator times the denominator to give me 2 times x plus 5. And then I have to go through and subtract the derivative of the denominator times the numerator, which is just 1 times 2x minus 3. And I divide all of that by x plus 5. And all of that is squared. So what is the derivative of the function? It's just 2x plus 10 minus 2x plus 3 all over x plus 5 quantity squared. Or if you go ahead and combine both of those, you just get that is 13 all over x plus 5 quantity squared. All right, for this one I'm going to use a little bit of different notation, but it's the same idea. This time I'm going to let the numerator equal u, and the numerator is 3x to the 5 over 2. And then the derivative of u is just 3 times 5 halves times x, and that 5 halves is minus 1 in the form of 2 over 2. So that's going to be to the 3 halves. And v is going to be x squared minus 4. The derivative of v is just 2x. So what is the derivative of the function? Same idea. I take, and it's always going to be the derivative of the numerator times the denominator. It must be in this order. So this is going to give us 15 halves x to the 3 halves times x squared minus 4. I want to subtract out the derivative of the denominator times the numerator, which is 2x times 3x to the 5 halves. And all of this is divided by the denominator squared. Let's go ahead and simplify this out a little bit. When I simplify this out, I get 15 halves x to the 3 halves plus 2 to the 7 halves minus, now I take 15 halves times 4, cancel out one of those 2's, So I'll get a negative 30x to the 3 halves minus 6x, and again there's an understood 1 there, so that becomes x to the 7 halves. And that is all over my common denominator, x squared minus 4 quantity squared. Now I don't like having this 2 here. I don't like having a complex fraction. But before I'm going to go ahead and do that, I also realize that this is x to the 7 halves, and this is also x to the 7 halves, so I want to go ahead and combine both of those. Left with 3 halves x to the 7 halves minus 30x to the 3 halves. Again, all over my common denominator. Now, the easiest way to get rid of that complex fraction is just to multiply the numerator and the denominator both by 2. And now I am left with 3x to the 7 halves minus 60x to the 3 halves all over 2x squared minus 4 squared.